To solve this problem, a good strategy would be to start off by creating a table of values, comparing the row number and the number of seats in each row. Now, we're given how many seats are in the third and sixth rows. Row 3 has 31 seats, and the sixth row has 37. Now, because we're told that the number of seats per row increase at a constant rate, that's very important, because that means this is going to be a linear relationship, so it's going to be increasing at a constant rate. And so because of that, we can fill in these blanks pretty easily. From 31, we're going to be adding something, but then you add the same amount 2 more times to get 37. So I can tell pretty quickly that that something is 2. You're going to be adding 2 in each case. Going backwards, for example, the second row would have 29 seats and the first row would have 27. Now that we have our table of values, we can find the algebraic equation that relates these two. And once we know that, we can quickly calculate how many seats are going to be in row number 20. I like to start by, well, first of all, I know it's going to be in the form of y equals mx plus b, because this is a linear relationship. And the slope is pretty easy to find, our m value, because that's the rate of change. That's how many times y is increasing as x increases by 1 each time. In this case, it's 2. So we know it's going to be 2x plus something. Now to find our b value, all we got to do is pick any x value. Let's start with 1. We're going to multiply it by 2 because we know that we need to do that. 2 multiplied by 1 is 2, of course. And what do we have to add to get from 2 to 27? We've got to add 25. So our b value is 25. And now we have our equation. So to find out how many seats are in row number 20, that would be replacing x with 20 and solving the equation. Pretty simple. We get 40 plus 25, which is 65. So the 20th row will have 65 seats. All right, hope that was helpful, and thanks for visiting JD's Preparation.